All right, so today is our maiden voyage on studying circles. So our objective is to learn basic terms associated with circles. So over half this book has been dealing with things that have angles to them, and now we're going to venture into the land of shapes that don't have angles. They do technically, but from the inside out, not from the outside in. But funny enough, we are going to go back and visit all those other shapes that do have angles, but in different ways. So we're actually getting to the end of being able to use theorem cards and postulates and properties on quizzes and tests. Because we actually aren't going to do chapter 10, because chapter 10 is the construction chapter, and we've been doing constructions all along. So we will do a couple theorems that are important from chapter 10, and then we'll go into chapter 11, which deals with areas of two-dimensional shapes. No flashcards allowed, because now those are all the formulas. So now you need to commit to memory all those formulas. And then chapter 12 is dealing with surface area and volume of three-dimensional shapes. Again, all the theorems deal with the formula, so you don't get to use them anymore. So what kind of stops happening, though, on your tests are the proofs, and it's all mathematical at this point. Okay? All right, so here we go. By the way, this is lesson 9-1, if you couldn't figure that out. Shh. So since we have so many terms to make it interesting, I'm just going to keep using a bunch of color. So what is a circle? A circle is a set of points. I know we're going to have complaints. A circle is a set of points in a plane at a given distance from a given point. And the symbol, strangely enough, looks like a circle. But to make sure it doesn't look like a letter or a number, you put a little dot inside of it. Okay? Now, that little dot is associated with what's called the center of the circle. So I'm going to talk about that, and then we'll go back and add to that particular thing. So the center of a circle it's the point that the circle is, let's see how to say this. It's the point that the circle is, no, distant. It's the point that the circle is uniformly there we go. We'll say it like that. That sounds ugly, but it's okay. So the center of a circle is a point that the circle is uniformly distant from. So when we think about a circle, we think about the outside like this. But it, in the definition, says it's a set of points, that's what forms this outside ring, at a plane, in a plane at a given distance from a given point. That given point is right here. He's called the center. So when I go back to my definition of a circle, and I am going to name that circle, it gets one letter, and it's named by the center letter, or by the center point. So if you've ever thought of there's a convenience store called Circle K. its symbol is a K inside of a circle. K is the center, is the point, that's the center of the circle. That's why they call it Circle K. Okay? It's interesting. Mathematicians should always shop there, but they're far and few between. Okay. And let's see what else. So, this word it's hard to come up with a good definition of it, but I'm kind of referring to it in both these. Let's talk about circumference. So, because a circle doesn't have edges, I can't talk about perimeter. So a circumference is as close to a perimeter that a circle can have. So I'm going to use the word perimeter since we all are familiar with what perimeter is. Circumference is the quote-unquote perimeter perimeter, quote-unquote, of a circle. So back to the definition of a circle, the set of points in a plane at a given distance. So it's the set of points, or the circumference, okay? Now, what is that distance from the given point? We know now the given point is the center. So what do we call that distance that circumference is created from the center to create that circumference? What's that distance called from the center to the circumference? That's called your radius. Yeah, it's too bad they can't see my hands flying in the air right now. So radius. So radius is the distance from the center of a circle to the circumference, which is what makes a circle, what we see of the circle, okay? Okay, so distance from the center of a circle to the circumference. That is a radius, okay? Now, we're going to switch gears and talk about, and then I'm going to draw a picture in a little bit. Let's talk about this guy, chord. Now, this chord has an H in it, okay? So it's different than the chord with a C. O, not the H, okay? So this is a segment whose endpoints lie on a circle. So what part of the circle would they be on? They would be on the circumference, okay? So if you've got a circle and you've got 2 points that are on the circle, where's that line? Give it a relationship to the circle. It's inside it most of the time, right? Okay? Because it says it's a segment whose endpoints, which is plural, means it has to touch the circle 2 locations. Okay? And it's a segment, which means it has to be straight, so it can't be this. It can't be a wedge. Okay? So it's a segment whose endpoints lie on a circle, meaning that it's inside the circle. Okay? Now, if I look at that chord, and it doesn't just start on one part of the circumference and go somewhere across the circle and hit the other side, but it's actually part of something larger. What would that segment be larger, a part of? What would be the larger thing that the segment could be part of? In general. A line. Okay? So, if we have a line that contains a chord of a circle, he now has a new name, and he's called a secant. Or, yeah, secant. Secant. So it's a line that contains a chord. Okay? And then we have a very special chord that passes specifically through the center of the circle. And his name is diameter. So this is a chord that passes through the center of a circle. And as an aside, who can tell me what the relationship is between the diameter and the radius? Isabel.
The diameter is twice the radius.
Okay. So 1 diameter equals 2, and we don't say radiuses.
Radii.
We say radii. Rachel.
For the chord, if it's not like specifically told it was like a diameter or like something like that, does the chord like mean like it goes through the point no matter what? Or
No, it goes through the circle. Anyway, just as long as its endpoints lie on the circumference of the circle, it's called a chord. If it specifically passes through the center, that one specific point, then it gets a more specified name called a diameter. Okay? And we can also, that chord could be on a secant because it could be part of a line. Okay? But the portion that goes from circumference edge to circumference edge, which edge doesn't sound right with circles, but anyway, that piece is still called a chord. But if it's part of a line, then that whole thing's called a secant. Okay? All right, I'll draw a picture in just a moment. One more thing. What if you have a line that only touches a circle in exactly one point? So you got to think about where would that line have to be to touch only in one point. Let's see. Dakota?
on the outside?
Yeah, touch on the outside. So that's called a tangent. And remember how we talked about trig? We have tangent. We have tangent here. So tangent means different things. And out on the beach, it means something completely different. Hey, you're a tangent. Sorry. A little math humor there. Yeah, ba-dum-dum. A guy who's tan is called a tangent. Get it? Bastian Raza. Do I have to say anything more? That guy's the tannest kid out there. A line in a plane of a circle. The reason why we have to state that is to say that, hey, it's in the same area as the circle, okay? So it's a line in the plane of a circle that intersects the circle in exactly one point. Okay? And we actually have a name for that point. You'll never guess what it's called. There's point of tangency. I swear they come up with the most innovative things sometimes. So the point of tangency is the point where a tangent intersects a circle. Point. Singular. Point. Okay? All right. Do I have enough room? I'm going to do my drawings on the next page. Okay. Everybody good? Okay. So let's draw a couple pictures. Oh, that is the most terrible center I've ever seen. That's a little bit better. Okay. So, this guy is called your center. This guy that passes from circumference to circumference edge, this guy is called your chord. If we have a chord that passes through the center, he's a diameter. If we go from the center to the circumference, that's called a radius. Okay. If we have a line that passes through the circle, so inside the circle we have a chord, but the whole thing is called a secant. And let's see. If we have a line that intersects the circle at exactly one point, he's called a tangent. And that one point is called the point of tangency. So what we're going to do is kind of explore that idea of tangent for just a moment. A little visual pick. Come on, you. Okay. Now I'm going to label this with some letters so that we can actually write some things. Oops, let's try that again. Okay. So from that one diagram, we can write a couple different statements. Number one, line AP is tangent to circle O. So remember, the symbol has the dot inside for the center because we need to distinguish from the symbol for the object versus the name of the object. Okay. We can also say that circle O is tangent to line AP. So there's the relationship goes both directions. Okay. We can say that A is the point of tangency. Now here's something that I didn't put in, and maybe I think we need to add that in as another vocab word. We'll get it in a second. Segment AP is called a tangent segment. Okay. So the tangent segment deals with the point of tangency to some other point on the tangent. That portion is just called a tangent segment. Okay. So let's see, do we want to do a vocab word on that one? Yeah, sure, why not? So it's a portion of a tangent starting with the point of tangency and extending to another point on the tangent. Such a long description for such a short piece, right? And if you thought that's where we were going to end, you're wrong. All right, so here's the interesting part. Everything we just talked about that applied to a circle applies to his three-dimensional cousin. And what's a three-dimensional cousin to a circle? Yeah. So we've got a sphere. Okay, somebody's going to get kicked out of here, and I'm going to change my recommendation on math class for them to go to. A sphere is a set of all points, and here comes the difference. With a circle, it was in a plane. With a sphere, it's all points in space. At a distance from the center. Guess what that distance is? A radius. Same idea. Okay. So same terms. for spheres as circles. So we're going to draw a picture, attempt to draw one, of a sphere. So you start with a circle, shock, shock, shock. And then you're going to draw a belt around it. But we draw the belt to try to give dimensionality that when it kind of dips forward, it's solid. And when it dips upward, it's dashed. So it's giving you the impression you're looking through this three-dimensional object. I'm going to put some points. I'm going to label some things. Oh, wait a second. That's not right. Don't draw that one yet. Okay. So what I'm going to do is to label a whole bunch of stuff that we see. So segment OA, segment OD, segment OB are called what? They're all radii. Notice that with radii, you start with the center, always, and go to the circumference, just like we did in a circle, okay? Segment BD, oops, sorry. What's he called? That's a diameter. Let's see, segment BC. He's called a chord. See that you can see some of the dash still there in the sphere. If I say line BC, oops, sorry, not BB, BC. What's that called? Secant. A is called a point of tangency. Let's see, I made them purple. Segment AT is called tangent segment. Line AT is called tangent. And what's the only thing I've forgotten? Yeah, the center. So we'll put them over here. O is the center. Okay? All right. A couple more words. We're going to make it. Cool. Page. I did point, PT. Okay. All right, here we go. Couple more words. Again, anything that applies to a circle applies to a sphere. So we've got the vocab congruent circles or spheres. That looks like surds, sorry. Those are circles or spheres. That have congruent radii. Okay. We have concentric circles or spheres. And they have circles or spheres that have the same center. Now, when it comes to circles, or cirdes, as I like to, seems like I'm trying to type or write all the time, circles, all I need to say is target. And those are concentric circles, okay? They all share the common center right there. So, target. Now, in the real world, we call that a bullseye, because that's from a game called darts. It also is in bow and arrows, archery. Okay. Now, the next two vocab words I think we've talked about before. Inscribed polygon. So inscribed means to write inside. Polygon is a shape. So this is, the definition means a polygon inside a circle. Whose vertices lie on the circle. So the vertices actually need to touch the circumference in order for it to be inscribed. And then we have circumscribed circles. So it's the second word that really dictates what's going on. So circum means around, scribe means to draw. So we're going to draw around a circle. So the polygon in inscribed is, we're looking from the inside of the shape. We're looking at the polygon. When we look from the outside, that's the circle. So it's the circles drawn around a polygon. Okay, where each vertex intersects the circle. Okay. So we've got this guy. And we're going to envision so I love that we could cheat a little bit. Okay, so what we can say is that the rectangle, or not rectangle, we'll call it quadrilateral. The quadrilateral is inscribed in the circle at the same time that the circle is circumscribed about the quadrilateral. And that's it. That's it. That's a lot. Quadrilateral. I need to learn to spell. Whew, finally.